Alright, so here's part 2 on problems dealing with the mean value theorem. So on number 2, what we want to do here is we want to figure out, does it satisfy the conditions of the mean value theorem, and then discover any, if they exist, values where the instantaneous rate of change, or the derivative, is equal to the average rate of change, which is the slope of the secant line. First of all, this function is defined in a closed interval, so that satisfies the first condition that we need. The function's continuous on the given interval, so that satisfies the second condition. However, the function's not differentiable on -8, 1, and here's why. The function's not differentiable at 0. If you were to take the function's derivative, you would get x to the -2/3, which is 1 over x to the 2/3. And so that function is not defined for when x is 0. So here's what we learned from that. We are not guaranteed the existence of some value c in the interval from -8 to 1, such that the instantaneous rate of change, or the derivative of f at c, is equal to the average rate of change over the interval from a to b. So it may still exist, we're just not guaranteed that it exists. So we're going to go through the procedure of trying to find it anyway, even though it's possible that there may be no value that works for this. So again, we set this up as before, and the slope of the secant line, in this case, the right side of the equation, ends up being 1. And so if we simplify this equation, we end up getting c to the 2/3 is equal to 1, which gives us two solutions, plus or minus 1. So on this one, it turns out that there is a value of c that satisfies the mean value theorem's conclusion. However, we just weren't guaranteed that it exists. So that's the difference. It may still exist, you're just not guaranteed that it exists. Alright, finally, let's take a look at a realistic example. So suppose we have this situation here where we have a person running the Chicago Marathon at a time of 2 hours, 37 minutes, and 12 seconds. We want to show that at some point during the race that they ran exactly 10 miles per hour. So let's let f of t represent the runner's position at time t, and let's let f prime of t represent the runner's velocity at time t. So note that f is continuous, differentiable, and is defined for 0 to 2.62. Again, I chose this particular time because it works out very nicely. It's exactly equal to 2.62 hours. Okay, so by the mean value theorem, there has to be some value c such that derivative at c is equal to the average rate of change over the course of the race. So basically what we've got here is f at 2.62. That's the distance that they traveled in 2.62 hours, which is exactly 26.2 miles. And at the start of the race, they hadn't gone anywhere. So this ends up being (26.2) minus 0. Again, f at 2.62 is 26.2, since after 2.62 hours they ran 26.2 miles, over 2.62, so this is exactly 10, and that's in miles per hour, since this is miles and this is hours. So thus, at some point during the race, the instantaneous rate at which they were traveling, so in other words, their instantaneous velocity, was 10 miles per hour.